Continuing in Algebra 2, Section 2, we're going to go from factored form into, I guess, more of a standard form, which different books call these different forms different things. So anyway, this is what I'm going to call standard form, ax squared plus bx plus c. Remember, roots are the same thing as x-intercepts, and we've gone back and forth on a lot of these things. And reminder that when we wrote factored form, we had the opposite, x plus 3, x minus 4. So it's the opposite of those two roots. Now the thing, and I'm going to worry about this in a little bit, is that my a value is dependent on, maybe I'll change colors, this a value is dependent on this last thing. So I'm ignoring that for right now, and what I need to do is FOIL or distribute. X times x is x squared. The outside is negative 4x. The inside is 3x, so negative 4x plus 3x would be negative 1x. And then 3 times negative 4 would give me negative 12. And if that's not quite making sense, I would encourage you to take it a step further. Okay, so what I would actually do, instead of plugging in 2 in for x here and here, I would actually plug it in up here. So I don't know why I just have that preference, but I don't know what a is, but plugging in 2 for x, 2 plus 3 is 5, and then plugging in 2 for this x, 2 minus 4 is negative 2. What I get there is negative 10a, and what needs to happen is that needs to equal negative 50. So to solve that problem, I need to divide negative 10 over, and so the a value needs to equal 5. So going back to, I'll go back to green, this piece, now I know that a needs to be 5 that I need to distribute into the problem. So the final answer I want to see is 5x squared. 5 times negative 1 is negative 5. And 5 times negative 12 is negative 60. And in order to check my work, I'm going to use a graphing calculator and just type it in, y equals 5x squared. And it goes minus 5x. I'll double check in a second. Yeah, 5x squared minus 5x minus 60. And when I go to the graph, you might not see exactly what but this, just hitting the graph, I can see that the x-intercept's negative 3, and then another x-intercept at 4, which is what was stated with the roots. And then also, if I go to second graph and I look at the table, I can see that when x was 2, I got negative 50 for that ordered pair. If I scroll up again, when x is negative 3, I got 0. When x was 4, I got 0, which was stated up there. So there's a little bit for each problem that you'll, I guess, just need to get used to. Oh, I guess I should have drawn that graph. That we had negative 3, we had 1, 2, 3, 4. We eventually found out that the y-intercept was negative 60. That's the y-intercept. But then we also had the ordered pair at 2, it was negative 50. This is a very lame graph, but you probably get exactly what I'm trying to get at. There we go. So in the next exercise, again, we've learned, it may seem like a long time ago, that the x-intercepts are always the opposite of your factors. So x equals negative 2, and x equals positive 5. Negative 2, 1, 2, 3, 4, 5. And then what they want you to do is practice a few different answers. So if I asked you to graph, maybe I'll use different colors. The top one, if you just FOIL it out, x squared, you'd have negative 5x plus 2x is negative 3x. But what I really care about is 2 times negative 5 is negative 10. That y-intercept is negative 10. 0, negative 10. So this graph is a little bit wider than some of the others. So if I look at the next one, just to change colors, the only thing that's different is we double everything. So it's going to be 2x squared minus 6x minus 20. So the y-intercept is a little bit further down, 0, negative 20, but it has the same x-intercepts. There we go. And then just one more, I'll just use this one. It's 4 times the original, so it's really just double the blue one. But like it goes all the way down here at this ordered pair. But again, it's the same y-intercepts. And you may recall a lesson we did a long time ago that by multiplying by different numbers in front is what we would call a vertical stretch. There we go. And you can play around with the graphing calculator if you have access to one. So how are we going to expand on that is what if we have a cubic polynomial? If you forgot, a cubic needs to end up with x to the 3rd power. And just like before, we need to figure out what the a value is. And maybe I'll do that one first. The a value depends on that 620. And we should have 3 factors then, which we do. We have 3 x-intercepts at negative 4, positive 2, and then 3, 4, positive 5. And then what we also need to, I guess what you could do is you could also put that you have 620 as an ordered pair on this. So remember, x-intercepts is the same thing as roots. Sometimes we call them zeros. We also call them solutions. And what we have inside of here are the opposite. So we have x plus 4, x minus 2, and x minus 5. So maybe what I'll do is just in a different order is plug in 6 for all of these x's. So 6 plus 4 is 10. So a times 10. 6 minus 2 is 4. And 6 minus 5 is 1. And what needs to happen is when I plug in 6, I need to get 20. So what we have is 40a equals 20. Well, if you divide the 40 over, I already know now that my a value needs to equal 1/2. And then from this point, I think what I would do is go back. All right? And it doesn't actually matter how you FOIL this out. You can only FOIL 2 things at a time, though. And my teacher used to teach me doing the last 2 first. I really don't know why. But let's go ahead and do that. If you FOIL those 2, you get x squared minus 5x minus 2x is minus 7x. And negative 2 times negative 5 is positive 10. And at this point, I like to wait until the very end to deal with a being 1/2. Because I like to FOIL, and it's not even FOIL, it's really the distributive property. X cubed minus 7x squared plus 10x, and then distribute the 4 to everything. So I like to line these up. 4x squared minus 28x, and 4 times 10 is 40. That way I can combine like terms. Please don't forget about this 1/2. That when I combine like terms, I can just go straight down. 10 minus 28 is negative 18, and then plus 40. So what's my final answer? I didn't mean to squeeze it all the way over here. Maybe I'll do this in blue. Is we have to distribute 1/2 to everything. So 1/2 x cubed minus, we'll just leave it as 3/2 x squared. Half of 18 is 9, and half of 40 is 20. And hopefully you've picked up on this already, that this last number is the y-intercept. So what needs to happen is if I were to connect my dots here, and I don't know exactly how high this turning point goes, but what needs to happen is that my final answer that I came up with needs to look something like this. So as I go to my calculator, just y equals, make that 1/2. And you can start all over and type this out a little bit cleaner than what I have. So we have 3/2 x squared minus 9x plus 20. And might change your window. You know, it says from -7 to 7, but I'm going to leave mine alone. But then go down to -100, up to 100, and just look at the graph. That looks pretty good to what I wrote down, based off of connecting all those points. And hopefully I have enough time to do this last couple problems. And what we use is this phrase of a double zero. And then we also have a y-intercept of 16, which I actually have to worry about that in a second. So what it means to be a double zero is x plus 2 happens twice. And remember, the factor is the opposite. And then another 0 at 4. Now the way I like to do this, and again, I'm just doing it differently, is you don't have to do the last two terms first. So as I FOIL the first two, x squared plus 4x plus 4, and then this other x minus 4, now I can distribute this. Maybe wait a second, just do some scratch work. Distribute x to everything. We're at x cubed plus 4x squared plus 4x. Now distribute -4 to everything. Minus 16x minus 16, which is kind of interesting because we get x cubed. That actually cancels out, so you don't have to write it down. Minus 12x minus 16. Now here's the problem, is we have a y-intercept of -16, and I wanted a y-intercept of positive 16. So what you can actually do is divide everything by -1 to get your correct equation. So -x cubed plus 12x plus 16. And before I show you my graph, let's look at a graphing calculator. So I'm going back to y equals, and we had negative in front. Let me just delete that fraction now. Delete, delete, delete. Plus 12x. I should have just cleared this out. This is going to take me a long time to do. Gotta even delete that. Delete. Let me just write plus 16. Delete, delete, delete. Alright. And then my window now is just going from -50 to positive 50. And if I look at that graph, what happens at x equals -2 is special. Is not only did we get -2, but it bounced off that graph. And we still had my y-intercept of 16. Let me jot that down. I know I didn't write it on the previous problem, but that's okay. And then my other zeros at 1, 2, 3, 4. That my graph looked like that. So you can count at -2, and if it looks like it's going below the x-axis, it is not. It is just bouncing off the x-axis right there. And that's what question 5 is asking you. How would you describe this cubic curve at the double root? It bounces off the graph. Now that's not really a math phrase. So let me give you the math phrase. Is times when we bounce. You know, you can bounce below, you can bounce above. We use the phrase that it is tangent to the x-axis. And you might have some familiarity from that word of tangent if you go back to geometry for a second and think about lines that are tangent to a circle only hit the circle at one point. So there's an example of a tangent line, and that's what's happening at x equals -2. Is it's tangent to the x-axis. I guess the x-axis is really what's tangent to the curve. So maybe I should clarify that. But at this point I need to be done with my video and you should be ready for the homework.